Hello class, I am here to give you notes on the binomial theorem in probability, unit 4. Here we go. So, binomial theorem, it looks really scary. It is a formula. You will have to know the formula, but there are so many easy ways to memorize this formula. It just looks scary because it has a lot of letters, but we're going to talk about what it means and how easy it is to set up. So how do I know if I'm able to use a binomial experiment or a binomial theorem? Well, that's going to be one of the challenges for you. So when I mix all these problems together, you're going to have to be like, oh, this is that binomial theorem problem. And here are some of the conditions you need in order to use it. There's a fixed number of observations. So like I flip a coin 10 times. That's the number of observations. So that we call that number n. The n in that situation, flipping a coin 10 times, would be 10. Each observation is independent. So one observation doesn't affect the other. In other words, when I flip a coin one time, it doesn't affect the outcome the next time. So that's another big thing. And then this is the biggest. Each observation falls into only two categories, success or fail. So for example, if I want to get tails when I'm flipping a coin, then the success would be getting the tails, the fail would be getting the heads. And like there's an example where a family is having a baby and it's either a boy or a girl. So if, I'm trying to find the probability that it's a boy, then the success would be having a boy, the fail would be having a girl, etc., etc. Okay. The probability of success is labeled as P. And the probability of failure is 1 minus P. We're going to call that Q. So Q is the fail. And then the probability of success P is the same for each observation. So for example, if I'm flipping a coin, getting tails, the probability I get tails is 50% every time, or 1/2. All right. So those are the conditions. Don't overthink those. Basically, we're just going to be doing a repeated experiment where I'm doing the same thing over and over, and I'm either getting one outcome or another. Okay. So win or lose, heads or tails, boy or girl, etc. Here is the formula. It looks scary. This n over r, it's not a fraction. This is actually NCR. Okay, so that's just another way to write n choose r. So I'm going to write it like this. And then p to the r and q to the n minus r. That's going to be really easy to memorize. Let's talk about the letters and then we'll do our first example. So n is the number of events or observations. R is the number of successes we want. So if I'm flipping a coin 10 times, what's the probability that I get tails 7 times? So the number of successes would be 7. And the probability of success would be 50% or 1/2. The P of R is the probability of R successes. That's what we're looking for. And then, like I said, this is big. Okay, and that n over r notation is n choose r, NCR. Okay, so let's do our first example. We're going to do all 4 of these together. So a fair coin is tossed 8 times. Pause. The total number of times that we're tossing the coin is 8. So that is n in my formula. I'm going to write down all the letters. Okay. What is the probability that it will land on heads 5 times? So heads is the success, and the number of successes I want are 5. So the number of successes is the R value. Okay. I want 5 successes. The P is the probability for success. So the probability for flipping heads is 1/2. The Q is the probability of fail, which in this case is tails. I know you may be thinking tails never fails, but in this case, that's our fails. And the probability for tails is also 1/2. The probability of P and Q should always add to 1. for 100%. 1/2 plus 1/2 is 1, so we're good. What else do I need to know? I have the N, I have the R, I have the P, I have the Q. I'm ready to do the formula. If you look at the formula, those are the only letters I need. So here is how it goes. N choose R is 8 choose 5. P is 1/2 raised to the R, which is 5. Q is the fails, so that's also 1/2. And then N minus R is 8 minus 5, which is 3. So this is it. Now let me talk about this. Okay, the way I memorize it is this. This bottom number is always, always, always the exponent on the first one. And then these two are always going to add to the top number, to this. So 5 plus 3 is 8. Hopefully that makes sense. But what I'm actually typing in my calculator is this. It's 8 choose 5. Okay. And then times 1/2 to the 5th times 1/2 to the 3rd. And that's going to give me the probability. So let's try it. So in your calculator, let's just do the 8 choose 5 first. 8 choose 5. Okay, so that's going to be 56 times, let's just type it in like this. I'm actually just going to take 56. I'm not going to write it down. I'm going to take 56 times parentheses. Look at the calculator. 1/2 raised to the 5th times parentheses 1/2 raised to the 3rd. Okay, hit math, enter, enter, and that's my answer, 7/32. I do want it as a fraction. I do not want a percentage. That's the answer right there. Okay, let's do another one. What is the probability it will land on tails at most 3 times? This one is a hard problem. This is a hard problem. What does at most mean? It means 0 times, or 1 time, or 2 times, or 3 times. That's what at most 3 means. 0, 1, 2, or 3. So this is actually a binomial theorem problem, but we have to do the binomial theorem 1, 2, 3, 4 times. So this is a crazy, crazy problem, but I'm doing it on the video so that you guys can see what you're supposed to do. So this time the success is going to be tails, because I want the probability that will land on tails at most 3 times. So the probability that it lands on tails 0 times is this. Again, we're flipping a coin 8 times. Let me write everything down again. So the N is still 8. For this trial, the success is going to be 0. The P is tails this time, still 1/2. And the Q is heads, still 1/2. And the P is, the success is tails because we're looking for tails. But really, since it's 50-50, it doesn't matter. So the probability that this lands on tails 0 times is going to be this. 8 choose 0. 1/2 to the 0. 1/2 to the 8th. Let's talk about it. Remember, this bottom number is the same as the first exponent, and the 2 exponents need to add to the top. So that's where I got those numbers from. Okay, and we will calculate that. And let's calculate it now, actually. So we're going to do 8 choose 0. Okay, times 0.5. I'm going to do 0.5 to the 0 times 0.5 to the 8th. 1 out of 256. And I'm adding these up because these are all ors. Okay, let's try the next one. So that was the probability of 0 times. What's the probability I get tails 1 time? So we're still flipping 8 times. This time I get tails once. Okay. So 1/2 is the probability I get tails to the first. These need to match. And then 1/2 to the 7th, because 7 and 1 adds to 8. All right, let's calculate it. Choose 1 times parentheses 0.5 to the first times 0.5 to the 7th. One over 32. All right, moving on. What's the probability that I get tails 2 times? Well, I'm still flipping 8 times. I want tails 2 times. Probability I get tails is still 1/2 to the 2nd power because I want it 2 times. Probability I don't get tails is 1/2, and 2 plus 6 will give me 8. Okay. Let's just change this to 8 choose 2 times 0.5 squared times 0.5 to the 6th. Seven over 64. All right, last one. I know this is a brutal problem. Believe me, I know. Probability that I get tails 3 times. So 8 choose 3. Probability I get tails is 1/2 to the 3rd. Probability I get not tails is going to be to the 5th power. Okay, so 8 choose 3 times, oops, that was 56. So 56 times 0.5 to the 3rd times 0.5 to the 5th. 7 over 32. All right. Whew. So the probability that I get tails 0 times or 1 time or 2 times or 3 times is going to be the sum of all these fractions. So my final answer is 1 over 256 plus 1 over 32 plus 7 over 64 plus 7 over 32. Final answer is 93 over 256. So again, that was like a really crazy problem to start out as, but hopefully, because we had to do the binomial theorem over and over again, it's kind of starting to click. Let's do a few more examples together that aren't so crazy like this. I'm going to do 2a. I'm going to skip the second part because it's similar to the one we just did, and I don't want this video to be crazy long, but I will try to do 3 and 4, okay? What is the probability? So a family has 5 children. What's the probability that 2 of the children are girls? Okay. Total amount of children, total amount of trials is 5. We want 2 successes, and the successes are girls, and we're going to say that having a girl is 50-50. So the probability of having a girl is 1/2. And the probability of not having a girl to fail would be boy is also 1/2. So I have everything I need to do binomial theorem. So of the 5 children, I want 2 to be girls. The probability I have a girl is 1/2. So the exponent on that is 2. the probability I don't have a girl is 1/2, and I need this number and this number to add to 5. So this number needs to be 3. That's it. That's the binomial theorem. So we're going to just type it into the calculator. We are going to do 5 choose 2 times 0.5 to the second times 0.5 to the third. And that's my answer, 5/16. Hopefully, just right now you were like, oh, this is not that bad. It looks bad. It's not that bad. We're going to skip to number 3, because number 3 isn't going to have a 50-50 chance of something happening. So it says, at a certain intersection, the light for eastbound traffic, a red is for 15 seconds, yellow is for 5, and green is for 30. Find the probability that out of the next 8 eastbound cars that arrive randomly at a light, exactly 3 will be stopped by a red light. Okay. So how many trials are there? It says out of the next 8. So that's the total amount of trials. How many successes do we want? So a success is red, and that's going to be 3. Okay, let's talk about the probabilities here. So let's add up these seconds. 15 plus 5 plus 30. 15 plus 5 is 20, plus 30 is 50 seconds. So the probability that I get a red light is 15 seconds, so 15 out of 50. Let's calculate that. 15 out of 50. You can leave it as 0.3 if you want. It's 3/10. Now, this next part's a little weird because this is binomial theorem, so I either have success or fail. So this is going to be probability of red, and then we also want the probability of just not getting a red. So that actually means that I get either a green or a yellow. So green and yellow, green is 30 seconds, yellow is 5, so 35 out of 50, which reduces to 7/10, is not getting a red. So this 3/10 is the success, and the fail is 7/10. So instead of using 1/2 and 1/2, we're going to use these fractions, but it's the same thing. So it's the same formula. So 8 choose 3. The success is 3/10, and the degree on that is going to be 3. The fail is 7/10, and 3 plus 5 will give me 8. So this is what I type into my calculator. Let's do this. Parentheses, math, and CR, 8 choose 3, times 3/10 raised to the third. I could type like a multiplication symbol in between. I really don't need it technically. Times parentheses 7/10 raised to the 5th. Look at how I typed that in my calculator, exactly the way I wrote it on paper. Okay, it's not turning it into a fraction for me, so I am just going to leave this as a decimal. 0.254. Beautiful. That's the answer. So then this one says, your soccer team has a 0.8 winning rate, probability of winning. Assuming this holds true for the next 3 games, determine the following. What's the probability that you will win 2? Okay, so total amount of games we're testing is 3. We want 2 wins. The probability that I win is 0.8. Oops. Which means the probability that I lose is 0.2, because remember, these have to add up to 1. So if I have an 80% chance of winning, I have a 20% chance of losing. And that's all I need to know to do this binomial theorem. 3 choose 2 times 0.8 to the second, these need to match, times 0.2 to the first, because 2 and 1 has to add to 3. Okay, type it in. That's it. If you can turn it into a fraction, that's how I like the answer. So this is 48 over 125. If you leave it as 0.384, that's okay too. So that's the answer. What is the probability that your team will not win any games? All right, so there's 2 ways to think about this. We could do it either way. We can think of the wins as a success still. So then there's 3 trials. But we don't want them to win any games. So the number of successes is actually going to be 0. But the probability that I win is still 0.8, and the probability that I lose is still 0.2. So this would be 3 choose 0 of 0.8 to the 0, 0.2 to the third. So I'm just going to be lazy and copy paste. This time we're going to do 3 choose 0, 0.8 to the 0, and 0.2 to the third. And then that's my answer. It's a rare possibility because my percentage winning is much higher than my percentage losing. So the fact that I'm not going to win any games is rare. That's one way to do it. If you wanted to flip it around and you wanted to now say losing is the success, you could have done, out of the 3 games, I want to lose 3 games. The probability of losing is 0.2. The probability of winning is 0.8. And just flip it around, but you would calculate and get the same answer. So I'm going to leave it the way that I did it, saying winning is still a success, but I want no successes in this case. Okay, so those are the notes. Go back and re-listen to them. Don't overthink it. I want this formula to feel really easy for you, even though it looks complicated. And I know that this problem was a little crazy because it was saying like either you get 0, 1, 2, or 3. So you have to do the binomial theorem over and over again. A little crazy. But hopefully overall it makes sense. Thanks, you guys.